Hello guys, welcome to i-tutor Academy. In today's session, we will start with the Unit 9, subsection 4, that is probability sampling method. In probability sampling method, in the category probability sampling, we shall discuss the following four designs: simple random sampling, systematic sampling, stratified sampling, and cluster sampling. One can also use sampling design which are combination of above listed one. Simple random sampling. Conceptually, the simple random sampling is one of the simplest sampling design and can work well for relatively small populations. However, there are many practical problems when one tries to use simple random sampling for large population. What is simple random sampling? Suppose we have a population having n elements and that we want to pick up a sample of size n. Obviously there are many possible sample of size n. Simple random sampling is a process which ensures that each of the samples of size n has an equal probability of being picked up as the chosen sample. As we shall see later in this section, this also implies that under simple random sampling, each element of the population has an equal probability of getting included in the sample. So here is table 2, simple random sampling is here. So you just go through this. It will more clear for you, and the equation also here. Sampling with and without replacement. We have implicitly assumed about that we are sampling without replacement. If an element is picked up once, it is not available to be picked up again. This is how most practical samples are, but as a concept it is possible to think in terms of sampling with replacement, in which case an element after being picked up and included in the sample is replaced in the population so that it can be picked up again. How is simple random sampling done? It is imperative to have a list of all the members of the population before a simple random sample can be picked up. Such an exhaustive list of all population members is called a sampling frame. Suppose we write the name of one such a member on a sheet of paper and thus have n sheet in a bowl, one sheet for each member of the population. We can then mix the sheets well and pick up one sheet at random to represent one member of the sample. If we want a sample of size n, we have to repeat this process n time and we shall have a simple random sample of size n consisting of the names of members appearing on the sheets picked. And we can also use a table of random number to pick up a simple random sample. In a table of random numbers, there is an equal probability for any digit from 0 to 9 to appear in any particular position. In table 3, we have a page of 5-digit random number and containing 100 such a numbers. The most important thing in using a random number table is to specify to the minutest detail the sequence of steps that has been decided before the table is actually referred to. We shall demonstrate with an example. Here is table is here, and suppose we have a population of, this is an example based on the table also here. The table of 5-digit random numbers are here, so you just go through it. The just practice will help you for more understanding. Okay, activity also here. And systematic sampling process by picking up one element after a fixed interval depending on the sampling ratio. An example, if we want to have a sample of size 10 from a population of size 100, our sampling ratio would be n by n is equal to 10 by 100 is equal to 1 by 10. We would therefore have to decide where to start from among the first 10 names in our frame. If this number happens to be 7, for example, then the sample would contain members having serial numbers 7, 17, 27, it's till 97 in the frame. And the systematic sampling in the previous example would choose 1 out of 10 possible samples, each starting with either number 1 or number 2 or number 10. This is usually decided by allowing chance to play its role, example by using a table of random numbers. Systematic sampling is relatively much easier to implement compared to simple random sampling. However, there is one possibility that should be guarded against while using systematic sampling: the possibility of a strong bias in the result if there is any periodicity in the frame that parallel to the sampling ratio. If the frame is arranged in an order ascending or descending of some attribute, then the location of the first sample element may affect the result of the study. And for example, if our frame contain a list of students arranged in a descending order of their percentage in the previous examination, and we are picking a systematic sample with a sampling ratio of 1/50. And on the other hand, if the frame is so arranged that similar elements are grouped together, then systematic sampling produces almost a proportional stratified sample and would be therefore more statistically efficient than a simple random sampling. Systematic sampling is perhaps the most commonly used method among the probability sampling design and for many purposes. Example, for estimating the precision of the result, systematic sample are treated as simple random samples. Stratified sampling. Stratified sampling is more complex than simple random sampling, but where applied properly, stratification can significantly increase the statistical efficiency of sampling. The concept: suppose we are interested in estimating the demand of non-aerated beverage in a residential colony. We know that the consumption of this beverage has some relationship with the family income, and that the families residing in this colony can be classified into three categories: high income, middle income, and low income families. If we are doing a sampling study, we would like to make sure that our sample does have some members from each of the three categories, perhaps in same proportion as the total number of families belonging to that category, in which case we would have used proportional stratified sampling. And what are strata? The strata are so defined that they constitute a partition of the population. They are mutually exclusive and collectively exhaustive. Every element of the population belonging to one stratum and not more than one stratum by definition. This is shown in the figure 2, a population with the 3 strata. Okay, so this is the example for strata. And proportional stratified sampling: after defining the strata, a simple random sample is picked up from each of the strata. If we want to have a total sample of size 100, this number is allocated to the different strata either in proportion to the size of the stratum in the population or otherwise. And here is the table. Proportional stratified sampling is here. Figure 3 is here stratified sampling and disproportional stratified sampling. And if the different strata in the population have unequal variance of the characteristic being measured, then the sample size allocation decision should consider the variance as well. It would be logical to have a smaller sample from a stratum where the variance is smaller than from another stratum where the variance is higher. So here is an example also. Table is here. Disproportional stratified sampling. Stratified sampling in practice. And the stratification of the population is quite common in managerial application because it also allows to draw separate conclusion for each stratum. And example also here. And the stratification required us to identify the strata such that the intra-stratum differences are as small as possible and inter-strata differences as large as possible. And cluster sampling: let us take up the situation where we interested in estimating the demand for a non-aerated beverage in a residential colony. Again, the colony is divided into 11 blocks, so called blocks A block through block K as shown in figure. So this is an example for blocks in a residential colony. And a cluster versus stratum. We can now compare cluster sampling with stratified sampling. Stratification is done to make the strata homogeneous within and different from other strata. Clusters, on the other hand, should be heterogeneous within, and the different clusters should be similar to each other. A cluster ideally is a mini population and has all the features of the population. The criterion used for stratification is a variable which is closely associated with the characteristics we are measuring. Example, income level when we are measuring the family consumption of non-aerated beverage in the example quoted earlier. On the other hand, the convenience of data collection is usually the basis for the cluster definitions. And cluster sampling in practice. Cluster sampling is used primarily because it allows for great economies in data collection costs since the travel related costs etc. are smaller, although it is statistically less efficient than simple random sampling in the most cases. This deficiency may be more than offset by the high economic efficiency that it offers. For example, to get a certain precision level, one might need a sample size of 100 under simple random sampling and the sample size of 175 under cluster sampling. However, if the cost of data collection is Rs20 under simple random sampling and only Rs5 under cluster sampling, it would be cost effective to use cluster sampling. And cluster sampling is rarely used in single stage sampling plans. In a national survey, a district might be treated as a cluster and cluster sampling used in the first stage to pick up 15 districts in the country. Some other forms of probability sampling like a stratified sampling, cluster sampling etc. is then used to go to a smaller sampling unit. If a frame has to be developed, then cluster sampling allows us to save on the cost of developing a frame because frame need to be developed only for the selected clusters and not for the whole population. Multi-stage and multi-phase sampling. In most large surveys, one uses multi-stage sampling where the sampling unit is something larger than an individual element of the population in all stages but the final. For example, in a national survey on the demand of fertilizers, one might use stratified sampling in the first stage with the district as sampling unit and the average rainfall in the district as the criterion for stratification. And multi-phase sampling on the other hand is designed to make use of the information collected in one phase to develop a sampling design in a subsequent phase. A study with the two phases is often called double sampling. In the first phase of the study might reveal a relationship between the family consumption of non-aerated beverage and the family income, and this information would then be used in the second phase to stratify the population with the family income as the criterion. Activity D, activity E are here, so you just try to do that. It is more clear for your concept. Non-probability sampling method. The probability sampling has some theoretical advantage over non-probability sampling. The bias introduced due to sampling could be completely eliminated and it is possible to set a confidence interval for the population parameter that is being studied. In spite of these advantages of probability sampling, non-probability sampling is used quite frequently in many sampling surveys. This is so because all are based on the practical consideration. Probability sampling requires a list of all the sampling units and this frame is not available in many situations, nor is it practically feasible to develop a frame of say all the household in a city or zone or ward of a city. Sometimes the objective of the study may not be to draw a statistical inference about the population but to get familiar with the extreme cases or other such as objectives. And convenience sampling. In this type of non-probability sampling, the choice of the sample is left completely to the convenience of the interviewer. The cost involved in picking up the sample is minimum and the cost of data collection is also generally low. Example, the interviewer can go to some retail shop and interview some shoppers while studying the demand for non-aerated beverages. However, such a samples can suffer from excessive bias from known or unknown sources, and also there is no way that the possible errors can be quantified. And purposive sampling, inconvenience sampling, any member of the population can be included in the sample without any restriction. When some restrictions are put on the possible inclusion of a member in the sample, the sampling is called purposive. And judgment sampling. In judgment sampling, the judgment or opinion of some experts forms the base of the sample selection. The expert are person who are believed to have information on the population which can help in giving us better sample. Such a sampling is very useful when we want to study a rare events or when members have extreme position or even when the objectives of the study is to collect a wide cross section of views from one extreme to the other. quota sampling, and even when we are using non-probability sampling, we might want our sample to be representative of the population in some defined way. This is sought to be achieved in quota sampling so that the bias introduced by sampling could be reduced. The sample size, how large a sample should be taken in a study. So far in this unit we have not addressed ourselves to this question. At this stage we will only mention some factors affect the sample size decision, and in later unit some of these ideas will be gone into in more depth. One of the most important factors that affect the sample size is the extent of variability in the population. Taking an extreme case, if there is no variability, if all members of the population are exactly identical, a sample of size 1 is as good as a sample of 100 or any other number, and therefore the larger the variability, the larger is the sample size required. A second consideration is the confidence in the inference, and made the larger the sample size, the higher is the confidence, and if many situation the confidence level is used as the basis to decide sample size, as we shall see in the next unit. In many real life situation, the factor of overriding importance is the cost of the study, and the problem then become one of the designing a sampling scheme to achieve the highest statistical efficiency subject to the budget for the study. If it is here that the cluster sampling and convenience sampling score over other more statistically efficient method of sampling, since the unit cost of data collection is lower. In this unit, we have looked at various sampling methods available when one wants to make some inference about a population without enumerating it completely. We started by looking at some situation where sampling was being done, and then found that in many situations sampling may be the only feasible way of knowing something about the population, either because of the time or cost involved, or because of the physical impossibility or practical infeasibility of observing the complete population. Also, the sampling can give as adequate result in many applications and can be preferred over complete enumeration, as it ensures a higher purity of the data collected, especially when the population is larger. And we noted that there are two basic method of sampling: probability sampling, which ensures that every member of the population has a calculable non-zero probability getting included in the sample, and non-probability sampling, where there is no such a assurance. Probability sampling is theoretically superior to non-probability sampling, as it helps us in reducing the bias and also allow us to quantify the possible error involved. But non-probability sampling is less rigorous, easy to use, and practically feasible, and gives adequate result in some applications. Among the probability sampling method, simple random sampling works the best when the population is homogeneous, but may have many practical limitations when the population is large. And simple random sampling ensures that each of the possible samples of a particular size has a in equal probability of getting picked up as the sample is selected, and it also implies that each element of the population has an equal probability of being included in the sample. And a systematic sampling starts with a random start and picking up members after a fixed interval down a list of all members called the sampling frame. And if the population can be broken down into smaller, more homogeneous subpopulation or strata, then the stratified sampling should be used, which allows higher economic efficiency, as the cost of data collection per element is reduced if members are physically or otherwise closer to each other as they are in cluster. The most large studies are based on multi-stage sampling, where different sampling methods are used at each stage. In some studies, multi-phase sample is also used, especially where the information collected in one phase is used in the sampling design of a later phase. And we have also discussed some of the non-probability sampling methods used in practice. If any member of the population could be included in the sample, we would get a convenience sample. And on the other hand, if the entry is subject to the judgment of some expert or expert who have a better knowledge of the population, we would have used judgment sampling. And if the sample is made representative of the population by setting quotas for element and satisfying different criteria. This is called quota sampling. Purposive sampling is a genuine name for all non-probability sampling methods where restrictions are used on entry. We have looked at all of these sampling methods to gauge their strength and weakness and also to find their applicability under different conditions. So here is self-assessment questions also. So 1, 2, 3, 4, 5. So all are based on this stratified, stratum, etc. and examples also, and so many questions are here. You just do it with your unit. You just revise and do it this question from unit only. These questions may be easy. In case any doubts, you can contact us also, we will help you. And for more IGNOU MBA videos, you just do like, share and subscribe our channel. Thank you so much.
i-tutor Academy presents IGNOU MBA complete syllabus coverage classes for individual students, semester-wise subject with online and flexible timing. For more details, contact on +916 238 21785.